Now, you'll notice that this lesson is called the Golden Rule, and it's probably the most important thing that I'm going to teach you in this entire course. It's certainly not the most exciting, not the most technical, but it is the most important, because everything else we cover means nothing if you run a script blind, and it takes something important down. So let's talk about what verifying actually means, why it matters, and what can happen when people skip it. So here's the thing about AI that a lot of people forget. It does not have access to your systems. It has never seen your environment, it doesn't know what's running, and what services depend on each other. It doesn't even know what will fall over if something gets deleted. It generates code based on patterns from its training data, and that code might be perfect, or it might have a subtle mistake that causes serious damage in your specific environment. The only way to know the difference is to check it yourself before it runs, and that is the golden rule. Verify before you run, every single time, no exceptions. So what does verifying actually look like? Well, I want to run you through these 5 steps every single time you get a script back from AI. Step 1, read it top to bottom. Not skim it, actually read it. If there's a line you don't understand, go back to AI and ask it to explain that line before you move on. Step 2 is identify every destructive operation. Look for anything that removes, deletes, clears, formats, or stops something. Those are the lines that can actually cause some real damage, so they certainly need your full attention. Step 3 is check the scope. Is the script going to run against one machine or every machine? One user or all users? Scope is where scripts go from slightly wrong to catastrophic. Step 4 is make sure we're testing it in a safe environment first, whether that's a virtual machine, a dev server, a test Active Directory. We'll cover the tests a little bit later on, but never run an untested script directly against production. And finally, step 5, verify the output before you act on it. If the script produces a list of accounts to delete, make sure you're actually reading through that list. If it's going to be sending emails, count the recipients. So we always want to make sure we look before we commit. So let me show you some of the commands that should definitely make you stop and take a breath every time you see them in a script. On the PowerShell side, things like remove items, remove AD users, basically anything that's removing, clearing, or formatting, we need to be really careful of. And then on the bash side, it's pretty much the same again. Anything that's using like an rm-rf, because an entire typo can wipe an entire directory tree. Anything that's overriding permissions or changing or killing processes, these are all really critical things that we need to look for. Now, none of these are reasons not to use the commands. They're all legitimate tools, but every single one of them should trigger a pause and a double check before you hit enter. And of course, we're always making sure we're running them in a dev environment first. So let me tell you about something that happens more often than people like to admit. A sysadmin asks AI to write a script to clean up inactive Active Directory accounts, so that's maybe users who haven't logged in for 180 days. It sounds reasonable, and the script comes back, looks right, so they run it. But what they didn't notice was the script had no what if flag. It just deleted immediately. And what AI didn't account for was service accounts. Service accounts run applications and schedule tasks. They typically don't have interactive login dates, so the script flagged them as inactive and has deleted them. And that could mean business applications stopped and those service accounts gone. The fix would have taken about 30 seconds. You would have added a what if statement to the list, you would have seen the service accounts in there and adjusted the filter, then run it properly. So that's it, 6 hours of downtime potentially fixed because of all a mistype, but it was absolutely preventable if we stuck to the 5 key verification steps. Another horror story is the stuff of nightmares for anyone who's worked in Linux. An engineer using an AI to write a bash script to clean up old log files. The script uses a variable for the directory path, which is a good practice, but a subtle bug was occurring. When the script ran, the variable was empty. So instead of doing an rm-rf against a specific directory, it just ran it against the entire root. And that's the entire file system. That was it, gone. The server was completely unrecoverable. They had to restore from backups, which could take several hours, And really the fix there was one line. Check if the variable is empty before using it. If it's empty, exit immediately. That's a 5-second addition that would have saved a huge amount of hours when it comes to recovery and lost data. And I've got another horror story here for you just to round it up to 3. This one is slightly less catastrophic but deeply uncomfortable. It's when a sysadmin uses an AI-generated PowerShell script to send password reset notifications to a test group of 12 users. The script pulls a list from Active Directory, but the filter logic was wrong, and it matched everyone instead of the test group. What that means is all 2,400 employees received an internal IT email full of technical language that meant absolutely nothing to them. So that's when the phones start ringing on the help desk, SLAs get absolutely blown out of proportion, and a company-wide follow-up apology has to go out. Again, the fix here was pretty simple. Before you send a single email, make sure you're outputting the recipient list to your screen and counting them. So how do you actually preview a script before it does any damage? Well, there's 3 techniques I want you to think about every time. There's probably more than this, but these are the 3 that are most critical. First of all, make sure to remember that PowerShell has a what if flag. The majority of PowerShell commandlets support this, and if you add the what if to any destructive command, PowerShell is going to tell you exactly what it would have done. Alright, so you use it before you commit anything, and that way you have a good understanding of what it's going to run. But of course, we still want to do that in a test or dev environment first. Secondly, output before you act. On any script that's going to delete things, modify things, or send things, make sure it outputs the target list first. Alright, that way you can pretty much get a good understanding of who it's going to be actioning against and verify that is what you want. And if you're doing something, for example, in Bash, you can do the bash echo dry run. So before any destructive commands in Bash are run, you replace it with an echo of what it would have done. All right. Or you use a dry run variable at the top to set it to true during testing and have the script echo instead of execute. That way, when you're happy, flip it to false and run it for real. These sorts of habits and getting them in your mind can really take seconds to add, but save you hours of recovery and apologies later on. And in any professional IT environment, unplanned changes are one of the biggest causes of outages. Not hardware failures, not malicious actors or hackers, unplanned changes. So someone ran something without telling anyone, something broke, and no one knows what changed or how to reverse it. And that's why change management is so important. It exists to prevent that. A change request is a formal record that says, here is what I'm doing, here is why, here is when, and here is how long it's going to take. You also have a rollback plan for what you're going to do if it goes wrong, and making sure that you've listed all the testing that you've done beforehand. AI-generated scripts absolutely need to go through this process. They can have unexpected side effects, they haven't been peer-reviewed, they haven't been tested in full production equivalent environments. Without a change record, there's no approval, no audit trail, and no accountability if something goes wrong. So the rule of thumb is pretty simple. If a script is going anywhere near production, raise a change. If it touches users, groups, permissions, or security rules, raise a change. If it can be easily reversed, raise a change. I cannot stress enough how important it is change management, especially in production environments. So here's what the right process might look like from start to finish. Step 1, you generate and read the script. Prompt AI, get your script, read every line, and make sure you're understanding what it does. Step 2 is verifying and testing. Run it with a what if or on a dry run. Make sure you're testing it on a virtual machine or dev environment and confirm that it does exactly what you need. Step 3 is raise a change request and document what your script does, why you're running it, and why you're planning to run it. And critically, what your rollback plan is if it goes wrong. Then step 4, you're going to want to get approval, so raise it to your change board or your manager or a peer, whoever your organization requires. And if you work somewhere without a formal process, at a minimum, tell someone what you're about to do. Step 5 is implement during a maintenance window. So these are low traffic hours. So if someone's available to roll back at 2 a.m., for example, that's much better than causing an outage at 2 p.m. And step 6, verify and close. Confirm everything worked as expected, update the change record, and close it out. This process feels like overhead when everything goes right, but it feels absolutely essential when something goes wrong, and you need to know exactly what changed and how to reverse it. So let me be direct about this. Production is not a test environment. I've seen people say that they'll be careful, they've read the script, and they're confident it's going to work. That's not the point. Even a script that's been carefully reviewed can behave differently in your production environment than you expect, and that's why we always test first. You've got three options really. You could have something like a local virtual machine, so something running on VirtualBox, Hyper-V, VMware, whatever you use. You go and test it on there. Otherwise, you can test it in something like a free tier up in the cloud. So maybe you've got a free tier VM in Azure or AWS, or you might even want to build yourself a dedicated test or dev environment to replicate what production looks like. And that way, when you're running the tests, it's matching what production looks like. This is really, really useful. It's the most realistic environment that you've got that isn't production, but make sure you're at least picking one of these and actually doing the testing every single time. So to bring it all together, the 7 rules are listed here. So always read the script in full before you run it. Identify every destructive command and understand what it targets. Confirm the scope, know exactly how many things will be affected. Use your what if or your dry runs to preview it before committing. Test in a virtual machine, dev environment, or just a safe environment, never in production, and raise a change request for anything going into a prod environment. And of course, keep a rollback plan, because anything you run that may be significant always needs to have a rollback if something goes wrong.